Hello. This video shows how to use the CML generator developed for the COMPASS project. Installing the generator and various other prerequisites are covered in the Installing the CML Generator video. You may wish to watch this first. For this video, I'm assuming all prerequisites have been met. If the model on which you plan on running the generator is not already open in Artisan Studio, you should open it by double-clicking the model as displayed in Artisan Model Explorer. This particular model is the test model provided with the installation. It contains two examples detailed in the COMPASS document 22.4. The top-level package, nmain, contains the two examples from 22.4, each in its own sub-package. The sub-packages are called monitored machine and producer consumer, respectively. Each one contains SysML model elements, for example blocks, interfaces, events, etc., plus some diagrams that explain these elements and how they relate to each other. In order to run the code generator, I need the ACS TDK toolbar to be visible. If it's not, I click View, Toolbars, ACS TDK Control. Here's the toolbar here. Studio remembers this setting between sessions, and unless I explicitly hide the toolbar again, it will from now on be visible. Really, monitored machine and producer consumer are each self-contained examples, and in a more real project we would probably not want to generate code for both, at least not at the same time. However, for me, these two together provide my initial acceptance test, so I'm going to generate the two as a pair by selecting the nmain package for generation, given it contains them both. The package selected for generation is known as the root package for code generation, or often just the root package, where context makes it clear that code generation is what we're doing. To run the code generator, I first click the Load Toolbar button here. This prepares Studio for code generation, but it doesn't start the generation. In fact, at this point, we have yet to tell Studio various things it needs to know before generation can actually start. For example, we have not said yet where we want the generated code to be put. To tell Studio this, we click another toolbar icon, the pink crayon, here. This brings up a dialog for us to give the information that's needed. We want to enter this information only once. We want the configuration to be stored. In fact, Studio insists on it. So the first thing we do is choose a path and a name for a configuration file that will be used to store the data. Like this. The default name is the model name. This is fine if you have only one configuration per model and all your models have unique names. Mine don't. Now we need to select the generator DLL we want, the one specifying the rules used to convert SysML to CML. This should have been copied to a known location as part of the installation prerequisite. To specify the DLL, we need to press the button with the ellipsis and navigate to the location of the DLL. This dialog defaults to looking for DLLs indirectly via .ini files, but can also look for them directly, and this is what we want. So we should change the extension expected to DLL in order to see it, and then double-click it in order to choose it. I still need to tell Studio where I want the generated files to be put. I do this in target directory here. But normally I'd want to generate these files into a COMPASS IDE project. So I'm going to leave this dialog unfinished for the moment and switch to the COMPASS IDE and create a new project. And I'm going to choose that I want a CML project, and I'm going to give the project a name like that. I'll click Finish. The project appears in the CML IDE browser, but it doesn't have anything in it yet. I can now go back to Studio and pick this folder example 2 as my target for code generation. Now Studio has enough information on how we want our code generated, so I can click Save and Launch, and the generator will start and remain running as long as I keep this model open, unless I explicitly stop it. In future, if I want to start this generation configuration again on this model, I need simply to open the model and load the generator as before with this button, and then select the root package, in this case nmain. Studio will look up the configurations related to this package and select one of them, but usually there is only one. The user should then simply press the play button, which is here to the right of the load button, to start the generator. The pink crayon button that we used before is only needed again if you want to create a different configuration or edit an existing one. Now this generator creates one CML file for each package within the scope of the generation. Because I selected nmain as the root package, we'll get a CML file for nmain itself, one for each of the sub-packages, and a couple more, because in fact we have another couple of packages lower down under producer consumer. Now nmain as a package doesn't make sense from a CML point of view, as it only contains sub-packages, so the CML file that it creates is best ignored. Equally, the two packages under producer consumer are best ignored. They contain sequence diagrams, and at the point I'm recording this video, the algorithms needed to generate CML code from sequence diagrams have not yet been implemented, so again we can ignore these. This leaves two CML files we're interested in, monitored machine and producer consumer, one for each example. And these contain blocks, operations, attributes, state machines, etc. And these are the areas of SysML for which rules have already been implemented. Studio will output a log file here in the ACS TDK log. This reports what it's doing with respect to code generation. The first time code is generated for a configuration, it takes a little longer, and here the log file tells you this. And it finished while I was talking, and I can tell that because it ends up with model saved to model cache over here. It will also tell me that it didn't actually commit any files to the file system. This is a safety feature that applies only the first time that code is generated, each time the generator started. The safety feature can be disabled, but I like it switched on. It gives me time to inspect the log and be confident I can turn the generator off again if it reports any issues before it has potentially overwritten something I want to keep. However, any change I make from now will result in files on the file system being updated pretty promptly. There's an alternative way to force it to output the files, and this is the Force Generate button on the toolbar. I'll press this now. There we go. Sometimes it will produce a dialog saying, "Are you sure?" Depends on your setup. Now I'm going to return to the CML IDE, and I'm going to press F5 in order to refresh it. And now we can see the various files that have been generated. The 2 of the 5 that I actually want, and one of these I'll open up now by double clicking. I'll open up producerconsumer.cml. There we are. Now you can see the generated code that corresponds to the SysML model within the producer consumer package. There are some errors in the code. This is work in progress, but I do want to show you what happens as a user continues to edit the SysML model. I'm going to go back to Studio, and I'll open up the block definition diagram within producer consumer. This describes the blocks within this package, and you can see there are 4 in the diagram. I'll use the diagram to add another block. And I'll call it foo. I'll also specify that each producer consumer has 1 foo in it. You can see from the generator's log that it's detected I've made a change, and it's working out how this changes the code and then rewriting the code appropriately. If I go back to the CML IDE now, it tells me the file has changed and asks me if I want to load the updates into the editor window. I'll say yes. I can now search for foo, and you can see that the addition has resulted in extra CML. Not a great deal of extra CML, but given that foo doesn't have any behavior yet, that's to be expected. If I now built a state machine for foo, I'd get a whole load more code. You might be wondering why the automatically generated code has so many comments. Well, as I said, this is a work in progress, and these comments will tell me whenever a rule is executed, where it starts and where it stops, plus what model element it applies to. This allows me to see very quickly where any problem lies, what's causing it and how it was reached. The intention is to keep it like this for the time being, even for versions of the generator that are released to COMPASS partners, as it will help in terms of reporting issues or even enhancement requests. The rule names and behavior used within the generator correlate very highly with those specified in the D22.4 document. Only very rarely, when differences are forced by implementation or very strong optimization reasons, is the correlation less than 100%. That's it for this video. I hope you found it useful and will find the generator and the other COMPASS tools useful and pleasurable to use in the future. Bye bye.